Human engineering has an impressive resume. We've left footprints on the lunar surface, and we've tunneled deep beneath the ocean floor to stitch entirely different continents together. Yet, if you ask modern engineers about the Great Pyramid of Giza, the confidence disappears. This 4,500-year-old mountain of stone is a logistical nightmare. So what if we decided to prove our dominance by building an exact one-to-one replica today? Could a modern construction crew, given a strict 5-year deadline, actually pull it off? The ancient Egyptians had the benefit of deep religious fervor. We have accountants. In the 21st century, every hour of labor, every scan, and every single stone has to be budgeted and paid for. Replicating this megalith is going to test our heavy machinery, but more importantly, it's going to serve as a massive financial audit of ancient ambition. The very first hurdle is finding the right plot of land. The pyramid weighs 6 million tons. That is the equivalent of stacking 6 million standard sedans in one spot. You can't build that on sand. If the bedrock isn't perfectly stable, the entire structure will collapse under its own gravity before you reach the halfway mark. The ancients learned this the hard way. Sneferu's bent pyramid started sagging during construction because of poor bedrock support, forcing the builders to frantically change the slope angle midway up. To prevent this, we have to spend $120 million securing 13 acres of premium Giza real estate, $5 million on deep seismic scans, and use GPS-guided lasers for flawless leveling. This diagram shows why preparation is so expensive. If the ground is off by a single millimeter at the base, that error extrapolates into a dangerous 14.7 centimeter tilt at the 147-meter apex. Then we pour a 4-meter thick reinforced concrete mat. That requires 500,000 tons of concrete, about 8% of the entire weight of the Burj Khalifa, just to anchor the foundation. Add all that up, and before a single historical block is even cut, the project's invoice has exploded to $550 million. Now we need the stones. Exactly 2.3 million blocks of limestone and granite, each roughly the size of a modern SUV. If a standard commercial stone factory started fulfilling this order today, cutting around 100 large blocks daily, it would take them 63 years to finish. To hit our strict 5-year deadline, we must deploy 250 industrial diamond wire saws into the quarries to slice through rock at maximum speed. Laying that cutting infrastructure costs $50 million upfront, and purchasing the raw limestone and granite itself tacks on another $1 billion. Running 250 of those diamond wire saws requires 20 megawatts of electricity per hour. Over 5 years, that is a power draw equal to the daily consumption of the entire country of Italy, adding a $155 million electricity bill. It takes a national-level power grid for modern engineers to accomplish what the ancient Egyptians managed with copper chisels and human calories. Slicing the rock is only half the battle. We still have to move 60 million tons of stone from quarries in Aswan to the construction site in Giza, a distance of 900 kilometers. We'd need an endless convoy of 2,400 heavy-duty trucks making 132 trips every single day for 5 straight years. The logistics alone will cost $200 million. Then comes the most dangerous phase of construction, lifting solid 80-ton blocks of granite, like the one sealing the king's chamber, 147 meters straight up into the sky. This chart visualizes a major physics problem. As a crane's arm extends higher and reaches further, its safe load-bearing capacity drops drastically. You can't hoist 80 tons on a standard long crane without tipping it over. We have to rent a specialized network of the world's most massive tower cranes and continually rebuild them as the pyramid grows. Combine that with a 3,000-person workforce over 5 years, and you're adding $700 million to the tab. Even equipped with state-of-the-art hydraulics and reinforced steel, placing these multi-ton blocks with millimeter accuracy pushes the absolute limits of 21st century mechanical physics. At this point, the 2.3 million stones are stacked, but the rough, stepped silhouette we see today is missing a crucial detail. To finish the job, the ancients encased the entire exterior in 115,000 perfectly smooth, bright white Torah limestone blocks.
This highly polished casing made the structure shine like a blinding beacon across the desert for miles. Replicating that exact aesthetic adds a final $250 million line item to the budget. Tallying the base-level invoice, we arrive at a staggering $2.95 billion, and that strictly covers raw construction, entirely excluding massive local taxes, astronomical safety insurance, and a custom power plant. Stepping back from the mechanical logistics, we have to face the harsh financial reality of dropping nearly $3 billion in the modern world. For that exact price tag, you could build the massive SoFi Stadium in Los Angeles, or construct the artificial Palm Jumeirah Islands in Dubai. The underlying motives are entirely different. Modern megaprojects are designed to generate an immediate return on investment through ticket sales, ongoing tourism, and luxury real estate. A massive stone tomb offers zero modern economic utility. Without the deep religious conviction of the ancient Egyptians, it is an absolute financial black hole with no capitalist justification. The Great Pyramid remains a pure anomaly of human willpower. It's an ancient miracle that modern society can mathematically price out, but could never culturally justify replicating.